Okay, we've got some multi-step algebraic equations. And notice I have the exact same equation twice. There's a reason for that. What we've got here is 3x plus 7 equals 10x plus 28. From what we've done so far, we never had this piece. We had things like 3x plus 7 equals 28. Or, let's see if I can cross cover that up. 3 equals 10x plus 28. Now we've got 4 things to deal with. 2 are numbers. 2 are numbers with variables. We are still going for the same thing. We want one variable on one side of the equal sign and one number on the other. So we need to start getting rid of stuff. What do we want to get rid of? It doesn't matter, but you have to get rid of something. So I'm going to get rid of the 10x. It's big. I might regret it, but it's got to go. So I'm going to do the exact same thing over here under 3x minus 10x. 3 minus 10 is negative 7x. Bring down that plus 7 because we have not done anything with it. Bring down equal sign. This is now gone. We don't have the 10x on this side anymore. Bring down the 28. So now we have negative 7x plus 7 equals 28. That looks a little more familiar. We need to get rid of that extra 7. It's hanging out there if we want it gone. Take away the 7, do the exact same thing on both sides. Bring down your negative 7x because you haven't done anything with that yet. Bring down your equal sign, and then 28 minus 7 is 21. Now we've got one more step. And doesn't this look familiar? This looks suspiciously like a one-step multiplication problem. We are going to get rid of the negative 7 and separate it from the x by dividing it out. And we're going to do the exact same thing on the other side. Negative 7x divided by negative 7 is x. Bring down the equal sign. Bad guy goes into town. Not good for the town. It's bad for the town. 21 divided by 7 is 3. Nice, right? So let me show you something that's interesting about these problems. It does not matter which one you choose to get rid of. You can get rid of whatever you want. Does not matter. So this time, let's get rid of the 7 just for fun. We're going to take away 7. Now that's zeroed out. So that leaves us with 3x on that side. But we also have to take away 7 from here. So now we have 3x equals 10x plus 21. And again, we end up taking away 10x. This is going to look suspiciously like the other, just in a different order. And we take away 10x here. That leaves us with a negative 7x equals 21. Separate the negative 7 from the x by dividing it out. Same thing on this side. And again, we have x equals negative 3. Now, what would happen if we got rid of, so we got rid of the 10x on this one, got rid of the 7 on this one. Let's get rid of the 3x. See, I'm going to put it right in the middle. Hopefully I don't mess everything up. So we're going to take away 3x. I should write the whole problem. That would make more sense. 3x plus 7 equals 10x plus 28 We're going to take away the 3x, take away the 3x. That's going to leave us 7 equals 10 minus 3 is 7x plus 28. Now we know we have to get rid of that 28 because we only have one number on the other side. That's an x. It doesn't look like an x, but it is. So let's get rid of that 28. Negative 28, take it away. That's nothing. Take away 28. That gives us negative 21 equals 7x. The 28s are gone. So same thing, we've got a one-step multiplication problem. We need to separate the 7 from the x. So we're going to divide out the 7, divide out the 7. Negative 21 divided by 7, bad guy goes into town. Bad for the town, 3 equals 7x divided by 7 is plain old x. Look at that. Doesn't matter where you start. You're going to get the exact same answer. It'll just be a little bit different in the middle, but the same number of steps, the same exact process, the same exact answer. Cool.